Hello friends, welcome to my channel. Here I solve LeetCode problems and preparing to the code interview. Today the problem number 2849, determine if a cell is reachable at a given time. You're given four integers sx, sy, fx, fy and a non-negative integer t. In an infinite to the grid, you start at with cell S6, Sy. Each second you must move to any of its adjacent cells. Return true if you can reach cell Fx, Fy after exactly t seconds, or false otherwise. A cell's adjacent calls are the 8 cells around it that share at least one corner with it. You can visit the same cell several times. Let's solve it. The easiest way to solve it is to use breadth first search. We can track the reachable cells after each second and update it each time. Let's do it. Let's save initial state. So it's set. Each cell we will save as a tuple. S6, Sy. Also we need a list steps. It's a possible difference from each direction by one. So up, down, left, right, and to diagonal direction. So we have 8 possible directions. -1, -1, 1, 1, -1, 1, 1, -1, 0, -1, -1, 0, 1, 0, 0, 1. So we have all 8 directions, and let's try to simulate the movement for some variable in range t. So we need to execute t times. Inside the loop we need to create new set, fill it, and after all calculations we will update old set. As a result, we need to check if final point with coordinate fx, fy in our set. And let's fill. For each cell, so with coordinates xy in S, and for each difference the x, the y in steps. Let's add new point to the new s variable. So new s add, we add tuple x plus dx and y plus dy. And let's check tests. Test passed, but the algorithm is quite ineffective because if we see the restrictions, t may be up to 10 billion seconds, so we will increase the result variable s up to 8 times because we have 8 directions, so the final result can be huge. So we need more optimal solution. Now let's check this solution first. Let's submit it. Yes, we have time limit exceeded. So let's find out some better solution. You can see on the first example that the shortest path from start to finished cell is the maximum distance from finish to start cell by horizontal or vertical direction. So in our case, we have 3 cells in vertical direction and 5 cells in horizontal direction. So the maximum distance is 5. So if we have t less than the shortest path, we couldn't find the solution. So if we have t greater or equal to the shortest distance, so we can find solution, and if we have some extra seconds, we have just change diagonal move to move right and down, so we can use any extra seconds this way. And we have one detail which we need to check before. If start and finish position are the same, so we started and we will finish at the same cell, and the t is equals to 1, this combination doesn't have solution because we can't move somewhere and return to the same position in 1 second. So we need to check it first. So if s6 equal to fx and sy equal to fy and t equal to 1, in this case return false. It's ours like base case, and the common solution is maximum of distance in horizontal or vertical direction, so s6 minus fx and sy minus fy, and this should be less or equal to t. In this case we can find a solution. So let's check the tests. Test passed. Let's submit it. It works and quite effective. So thanks for watching. See you tomorrow. Bye.